So what we did on Friday was we looked at the slope between 2 points. So I'll go back up here. I'm going to erase some things because I tried to record this earlier and the sound didn't work. So before we had the 2 points and we would have drawn our triangle, that would have gone like this to figure out our slope. And we would have just counted, right? We would have said, okay, from -3 to 3, we had 1, 2, 3, 4, 5, 6. And from 4 to 8, we have 1, 2, 3, 4, right? So when we're doing this, we wanted to try to count without actually drawing something. So we had, this was at 4, this was 8, this at -3, and this at 3. And I told everybody in class, how do we go about finding that? And that's when some people realized, well, we're just going to subtract here. Get this. Oh, and we're just going to subtract here to get, well, actually, the other way around. Well, it should be like this, -3, 3, -6. And you get that as you rise and run, as 4 over -6, which becomes -4 over 6, which reduces down to -2 over 3. And if we saw that, if we went down 2, 1, 2, went over 1, 2, 3, if I had done a better job of drawing this line, it would have actually crossed right there as well. So that was our big formula that we had, that we came through, was we said, okay, we have 2 points here, and our first set of points we call x1 and y1. Our second set of points we call x2 and y2. The little numbers on the side just help us correspond which set they belong to. This belongs to the first group, this belongs to the second group. And then our slope formula is just we subtract our y's, and I was showing here, it doesn't matter which order. So even though I called 10 y2 and 7 y1, if I switch the order, I actually get the same answer. Just what ends up happening when you have negative over negative, it becomes positive. And again, why that works is when we subtract the y's, we're calculating our rise, and when we subtract the x's, we're actually calculating that run. Subtraction is just doing that counting. How many are between these two numbers? That's what we were asking our questions in our head for the first 2 slopes. The other thing that we talked about was how do we make things parallel? How do we make things perpendicular? And we looked at in the class, we looked at a square, and it was kind of an off-centered square like this. And we found out that the slopes were 2, 2, -0.5, and -0.5. Ooh, I gotta write it out better. And what we remembered was that these 2 lines are parallel. They're never going to touch each other. These 2 lines are parallel. They're never going to touch each other. And the other lines intersect on a square at 90 degrees, which is why I used it as a great example for it, because then we saw that, well, if we have parallel slopes, it means that our slopes are exactly the same. 2 and 2, those are parallel slopes. Our perpendicular slopes, the fancier way of doing it was we called it negative reciprocals. And what it meant to be a negative reciprocal is that we just flip it. So you see here, this slope is really 2 over 1. So flipped is 1 over 2, and we change the sign. It was positive, now it's going to be a negative slope. And that's the basis of what we covered. We're covering, again, the next few days, parallel and perpendicular again with our next lessons. So don't worry too much about that, but for today, just focus on what this formula here and how to use it between 2 points. And then know that parallel, they're the same. Know that perpendicular, they intersect at 90, and that they are the flipped and changed signs.